All right, I'm going to look at some problems involving potential difference. So, the title of the problems are potential difference. So a lot of times people get confused because it talks about this whole infinitely far away business. So really the reason why it mentions that is because it's saying that, something has a potential at one point, right? So if something's here, it has a potential. In order for it to have a potential difference, then it would have to move to some other location, and then the difference would be between point A and point B. So if we're dealing with, this point and something that's infinitely far away, we're saying that the position infinitely far away, way over here, is where the potential is 0, and therefore whatever the magnitude of the potential at that point is actually the potential difference. Okay, so don't get confused by that. So the first one says just find the potential difference between a point that's infinitely far away and a point that's 1 centimeter from a proton. Okay, so here you have, you've got a proton, and then right over here we're seeing what is the potential there. So remember that the equation in this case, when we're dealing with a point charge and we're trying to find potential, which is volts, is K, Q over R. Okay, so all we have to do is take 9 times 10 to the 9th and then multiply it by the charge of a proton, which is 1.6 times 10 to the negative 19th, all over their distance apart. So it would be 0.01. Okay, so we just get 9 EE to the 9th times 1.6 EE to the negative 19th divided by 0.01. Gives me a potential difference of volts of 1.44 times 10 to the negative 7th volts. Okay, now let's go ahead and just do one more on this. So this one will be a little bit harder. So we've got 4 particles with a charge of 5, 3, 3, and negative 5 microcoulombs and placed at a 2 by 2 meter square. Determine the potential difference between the center of the square and infinity. So what we need to do is we need to figure out the potential as a result of all of these charges there, and then that would be the potential difference from that point all the way to infinity. Okay? So if I have, I've got a 5 microcoulomb, I've got a 3 microcoulomb, I've got a 3 microcoulomb, and I've got a negative 5 microcoulomb. Okay, so here's my box. Okay, and it's 2 by 2. So we want to know what is this distance, right? So we're going to have 1, 1 here. So actually the distance here would be the square root of 2. Okay, so, and that would be the distance for every one. Okay, so we just need to do KQ over R, right? So volts equals 9 times 10 to the 9th times, and we've got 3 times 10 to the negative 6th all over the square root of 2. And then we're going to multiply this by 2, right? Because there's 2 charges. And then we're going to have volts is equivalent to, and if you look at this, right, you have a negative and you have a positive 5 microcoulomb charge, right? So if we were to figure out the volts of one and the volts of another, one is going to be positive and one is going to be negative. So they are going to completely cancel out. So we don't even have to do that, right? So if we just figure out this part of it, that will be our answer, right? So it sounds a lot harder than it really is, okay? So we'll just take 9 EE to the 9th times 3 EE to the negative 6th, and then divide that by the square root of 2, and then multiply it by 2, and we'll write that in scientific notation, 1, 2, 3, 4. So the answer would be 3.8 times 10 to the 4th volts. That's it.